So now that we've talked a little bit about confidence intervals, let's talk a little bit about how to find the confidence interval. First thing you need to be able to do before, we're going to talk, in this section, we're going to talk about finding the confidence interval, the population mean, if we know sigma. Now again, remember, sigma is a parameter. It's the standard deviation of the entire population. So if I want the confidence interval for the population mean for a known value of sigma, first thing I have to look for is I have three conditions that have to be met. Okay, your first three conditions. So number one, your sample has to come from a simple random sample. Okay, that's pretty basic, a simple random sample. The second is the sample mean distribution sample mean distribution has to be normal. Okay, so that's where the central limit theorem comes into play. All right, the central limit theorem comes into the play because that means n is large enough, and our book calls large enough 30. I don't know where they get 30 from, but our book, if you should have read, 30 is what they say n should be. And then the third thing is each sample is independent. Okay? Now, if you read about it, it said that the samples were independent, and then it had something about replacement and non-replacement and all that stuff. Basically, that means if there is replacement within the sample or in the population, make sure your sample size is large enough. Okay? And so, if there is replacement, or even if there isn't replacement, if your sample size, or if 10 times your sample size is less than the population size, then that's going to be enough independence there. Basically, they're saying that your population is big enough that by putting those back in, the chances of getting the same one are less likely. And so you're looking at a large population size you can have replacement in, and that still kind of gives you the independence there. Okay. So those are the three conditions that have to be met in order to calculate a confidence interval. Okay. So let's talk about calculating the confidence interval. Okay. So you choose a simple random sample from a population when mu is unknown and sigma is known. Okay. We're going to look at mu plus or minus z star times basically the standard deviation of my sampling distribution. You should recognize that from the sampling distribution of your, or the standard deviation of your sampling distribution. So really, what is z star? And again, you've read this out of your books, but z star is standard deviations. Or z-scores. Okay, because if we're dealing with a normal population, which we've kind of talked about, if we're dealing with a normal population, basically we're saying, and we're talking about a 95% confident interval, let's say, that we're saying we want 95% of my data to be within this region right here. I want 95% of my data there. So I have my two tail ends. Let me grab a different color here. I have my two tail ends here and here, so that should be 2.5% of my data, and that should be 2.5% of my data. So then the question is, what z-scores allow me to give me this kind of relationship? And that's what z-star is. Okay? So your z-star is your how many standard deviations away from the mean you're going to be plus side and minus side that gives me 95% of the data in between. We've talked about this before, that if I'm one standard deviation away from the mean, then 68% of my data is in there, and so on and so forth. And so what we can say then is that if I'm doing a confidence interval, and they're pretty basic. Usually we have a 90% confidence interval, a 95% confidence interval, a 99% confidence interval. Those are some of the basics. Then your z-stars are going to be, hold on, 1.645 and 1.960 and 2.576. You can find these values, again, using your A table. If you go back to your A table and you look at them, okay, then you could tell me how many standard deviations away. Again, the whole idea, though, is to get, you're going to have two tails on it. You're going to have stuff in between. All right? What's going to give me 90% of my data in between there? So that's going to be 5% down here and 5% up here. All right? So you've got to, so what, if I go to my table A, if I look and I go table A, which one of these is going to give me a 0.05 in the middle? So I go 0.05 is going to be about 0.495, if you can see. I don't know if you can see that. But you've got 0.050 at negative 1.64. Oh, look at what we said. 1.64. That gives me my 5% below, just like we talked about. That's where those numbers come from. All right? So those are my z-stars right there. That's basically, we're saying, go that many standard deviations away from my mean, and that's going to give me my confidence interval. We'll look at an example here in a second of the confidence interval. But before we do that, there are some steps of inference that we need to talk about. And there are 4 steps that I always want to see whenever you do any calculations for inference. Okay? Your 4 steps for inference. And you should label them. I mean, go ahead and label them. Step 1, step 2, step 3, step 4. So step number 1, step number 1. Is identify the parameter. Okay? Identify the parameter. Identify the population parameter, or the population of interest, and the parameter you are drawing conclusions about. Okay, that's step number 1. Step number 2 is conditions. Okay, in different inference problems, we're going to have different conditions. Right now, we only have one set of conditions. We have those 1, 2, and 3 conditions we have to meet if we're going to do a confidence interval. So we always have to check and make sure that conditions are met. Check and make sure appropriate conditions are being used. Okay. Step number 3, calculations. So each inference problem is going to have some kinds of calculations that go along with it. Okay? So make sure the conditions are met, carry out the calculations. And then step number 4, they're all very important, but step number 4 is an important one, and that is the conclusion or the interpretation. Basically interpret the results and then put them into context for your conclusion. Our book talks about the 3 C's, and those are conclusion, connection, and context. Okay. So these are the 4 steps that I want to see every single time you do an inference problem. Okay? And these confidence intervals are inference problems. So I'm going to go ahead and do example on page. Why don't you go ahead and take your books out and open up to page 632. We're going to look at a problem on page 632, and I'm going to go through it step by step and show you exactly what I want to see whenever you answer a confidence interval problem.